everybody. In this video, I'm going to be explaining the expectations for the final paper, which is due on July 1st, which is the last day of the semester. Now, you're welcome to submit it on July 1st, but I would recommend that you submit it on June 28th, which is the Friday before July 1st, because if you submit it then, I will grade them over the weekend and you'll have one last chance to make any edits or changes and resubmit the assignment for a higher score if you didn't like the score that you got on the final paper. So I would highly recommend planning on finishing this paper by the 28th of June, just so that you have that chance to get back points if you miss any. So this final paper should be relatively easy to write because you've been working on it all semester in the application assignments. So in application 3, you explored which topic you wanted to look at, identified your population, and considered variables of interest, and then you conducted your survey. And in these last few application assignments we've been doing, you've started organizing, summarizing, and making calculations based on the results of your survey. So when you write the final paper, there is a suggested outline, and I would appreciate it if you follow this outline because that does make it a lot easier for me to grade it. But keep in mind that this is a paper. So in the application assignments, you guys have been responding to prompts, and they haven't necessarily been organized into paragraph form. So when you're writing, say, like the introduction or overview, there's these questions that I've given you to kind of give you an idea of what I'm looking for in the introduction or overview. But this should be formatted as a paragraph that's neatly written. And that is one of the things you'll be graded on, is whether or not your paper is at an acceptable level for college level writing. So you shouldn't just be going through and answering each question in kind of like disjoint sentences. It should be a cohesive, understandable paragraph. So the first bit of your paper will be the introduction or overview. Then you'll explain how you collected your data. So you'll basically summarize the process that you used, and most of you guys use surveys. So you'll describe that. You'll say how many responses were collected, what types people responded to your survey, and so on. And then you'll share your results. And I'm actually going to go through these as an example, so I'm not going to read these through. You can read it in the assignment. But I do want to talk about how you'll be graded. So the final paper is worth 100 points, and this assignment is worth 15% of your final grade. So it's a pretty significant portion of your grade. And if you include all of the different categories I'm going to talk about in this video, you should be able to get an A on this paper. So my intention is that this assignment is not a super hard assignment because you've been working on it all semester. And this is a really good chance to boost your grade if there were any of the tests that you maybe didn't do as well on. So the way that I'll be grading this is that you'll get 10 points for college level writing. So like I mentioned earlier, it should be well organized. You should have paragraphs that are cohesive and make sense as a paragraph versus like disjoint answers to the questions in the suggested outline. So you get 10 points for that. Then you get 10 points for clearly describing what your research question is and why you chose it, why it's important or of interest. And then you get 10 points for correctly collecting the data and describing how the data was gathered. And then the bulk of the assignment, or the bulk of the points, comes from analyzing your data using correct statistical techniques. So your analysis should include confidence intervals and hypothesis testing. So I'm going to go through an example to show you what that could look like. And remember, there's several different types of hypothesis testing, depending on what type of question you're asking. So again, I'll talk about this in an example. And then you get 10 points for displaying your data and results in an easily understandable way. So things like tables, charts, graphs, and basically the things that you were working on last week in your application assignment where you made histograms and pie charts and so on. And you want to make sure that these tables, charts, and graphs are relevant to the question that you're asking. And then you get 20 points for drawing a conclusion to your research question based on your data. And this is also the category where you'll point out any limitations your study might have. Like maybe your sampling method was biased. So it may not actually represent the population you were planning on studying, but it might be a biased sample, or maybe the way that you asked the question could have produced biased results. So that's what you'll include in your conclusion. So this is how it's going to be graded. And I want to walk you guys through an example of what this would look like. So let's say, for example, that my research question was, does the year that someone is in school impact their GPA? So like if you're a freshman, sophomore, junior, or senior, does your progress in school impact what GPA you have? And just thinking about it, I would probably think, yeah, it probably does impact it. Because, as you move through your schooling, maybe you have harder classes. So you would expect that maybe seniors would have a lower GPA than, say, freshmen would. That's one of my thoughts about it, but I'm going to test it out and see. So, to get these 10 points, I would want to clearly describe what my research question is. So, you want this to be super succinct and really easy to understand. So, my research question is there any impact between the year that you are in school and your GPA? Then I would explain how I collected my data and basically explain how I chose my sample. So I might say, okay, well, I made this survey, which I created here, that says, what year of school are you in? What's your GPA? And I gave them multiple choice options for the year of school that they're in. And I gave them a short answer text box to describe what their GPA is. So that would be how I collected my data and how I designed my survey. And then I would also explain how I sent out my survey. So I might say, I gave my survey to 30 different people in a variety of different classes that I'm in. Or maybe you sent out your survey by texting it to a bunch of your friends. But you explain how you collected your data and in what format you collected it. And then you want to analyze your data using correct statistical techniques. So if you did a survey, the way that you can see the results of your survey is to go to responses and then click on this button that says view in sheets. And the reason you want to do this is because it's going to give you the raw data that you collected. Now, I just want to preview this with, I didn't actually conduct this survey. I just made up a bunch of numbers for the GPAs of different people. Now, obviously, your data, you actually did send out a survey and you collected it. So your data would hopefully reflect the results of the question that you were asking. But this was just something I threw together today. But one thing that you might notice as you scroll through your data is that some of the data isn't in a format that's helpful. For example, this one person that hypothetically took my survey said that they're a junior and that their GPA was a 4.0 until they took biology. Well, that doesn't tell you what their GPA actually is. So there's two things that you can do. If you feel like it would be reasonable to estimate their GPA, if they put in something like this, you could do that. So I might say, okay, well, if they took biology and they're a junior and maybe they did really poorly in biology, it probably didn't lower their overall GPA too much because they've taken a lot of classes and biology was just one class out of a lot of classes. So maybe I might say, okay, well, probably their GPA is about a 3.9 right now. The other option is that you can delete that result from your survey because the data that was collected wasn't usable, and so you can just delete it. So let's say that I delete that one, but on this one where they say, I think it's somewhere between 3.5 and 3.6, I'm just going to say, okay, we're going to say that their GPA was 3.55. I'm going to fix that data there. Because what you want is if you have qualitative data, which remember is data where you categorize the people who responded to your survey into different categories, that in that case, you're going to want the categories to be clearly defined. So this happened naturally because of the way I designed my survey, because I made it a multiple choice one. But if you had them type in what year of school they were in, you might get different spellings of the word freshman. You might have people type out a paragraph instead of just saying a single word. And so you'd want to go in and fix your data so that all of your categories look the same. And the reason why this is important is because you'll want to be able to sort your data to make it easy to create histograms or pie charts or various things like that. So, for example, I might want to sort this range by column B. And if the word freshman had been spelled in different ways, or if someone had said, well, I'm in my first year here. Well, that means they're a freshman, but it's like when you sort it alphabetically, it's not going to sort it in that way. Um, so uh, I guess that's kind of the first step to analyzing your data is go through your data and make sure that the formatting of your data actually makes sense. And once you've got your data all organized and formatted in a way that makes it easy to sort the categorical or qualitative data, and all of the quantitative data are written in numbers, then you're ready to start analyzing your data. So, to receive full credit for this on the final project, your analysis needs to include confidence intervals and hypothesis testing. Now, remember that there's multiple different ways you can do confidence intervals and multiple ways you can do hypothesis testing. And the method that you choose depends on your question and the type of data that you collected. So, in this case, I have the question of trying to figure out if there's a relationship between the school year that people are in and the um, GPA that they have. So when I look at the two different types of confidence intervals, and I'm just using the formula sheet from test 2 to summarize this, we have confidence intervals for means and we have confidence intervals for proportions. So in my data set, I think that it would be most useful to do confidence intervals for means because it would be helpful to figure out what the overall mean GPA of students is, and then compare that to the mean for freshmen, sophomores, juniors, and seniors, and to figure out the confidence intervals for all of those different means. So, for my question, I think it would be helpful to do confidence intervals for means because proportions have to do with what fraction of people maybe got A's or B's or whatever. And you could still do confidence intervals for that if you split up your um, GPAs into maybe categories and then looked at what percentage of people got each one of those. But I think it would be more useful to look at the um, mean or the average GPA. Another example of something where confidence intervals for proportions might be helpful is if you are looking at a question of maybe like, um, what percentage of Skittles are blue or green or purple? And like, what are the different percentages of colors in the average Skittles bag? That would be an example of proportions because you're going to be looking at the percentage of Skittles that were blue or green or purple and so on. So proportions have to do with when you're looking at percentages, and then the means are obviously when you're looking at an average. So since I want to do the confidence intervals for the means, first of all, I need to figure out what the means are. So I'm going to be looking at several different means here because I want to look at the mean GPA overall, as well as the mean GPA of just freshmen, just juniors, just seniors, and just sophomores. So I'm going to organize these kind of like this. So this will be overall freshmen, and obviously you guys can organize this however you want. This is just for your calculation, and then you're going to summarize these results in your paper. So we've got freshmen, sophomores, juniors, and seniors. And I want to find out what the mean of all of these is. So I'm going to use the average function. And I'm going to average all of my quantitative data. And then I'm going to average just my freshman data, which is this data here. And then I'm going to average the sophomore data, which is down here. Whoops. So I think that ended up working out since it was the last one, but there we go. And then the junior one, will average those. And then for seniors, we've got this. Okay, so it looks like the overall GPA is 3.26, or from our sample at least. And then we've got the freshman, sophomore, and junior average GPAs listed here. And then the other piece of information we're going to need in order to calculate confidence intervals is the standard deviation. So the standard deviation can be calculated with sdev.s because we're finding the standard deviation of the sample. So the overall standard deviation is going to be the standard deviation of all of the data set. And then the other one is the standard deviation of just the freshmen and the standard deviation of just the sophomores. And the standard deviation of just the juniors, and so on. So it would look kind of like that. So those are my different calculations. And then in order to find the confidence interval, I'm just going to use this formula to find the error. So I'm going to do 1.96 times S, where S is the sample standard deviation, divided by the square root of n, which is the sample size. So my error, or my overall error, I should say, is going to be 1.96 times our sample standard deviation divided by the square root of, I guess I should actually count the number in each one. So let me fix that really quick. So we'll say the count of the number of people that answered my survey, or let's actually call this the survey size or sample size. Sorry about that. So one way you can do this, you can go through and count how many responses you got to your survey, or you can use the function count and just count the number of people that responded. And that tells you, you have to use count A because that counts it even if they're not numbers. So that tells me I got 28 responses in my data set. Then I'd also want to count the number of freshmen that responded, and count the number of sophomores. sophomores that responded. And the number of juniors and the number of seniors. Okay, so this is the sample size for each of these categories. And if I wanted to find the error, I would use that formula, which I forgot what it was, 1.96 times the standard deviation divided by the square root of the sample size. So I would do 1.96 times the standard deviation divided by the square root of the sample size. So that's my error. And I'll just copy and paste that formula all the way across because Excel's really nice. It adjusts your formula when you copy and paste it across columns. So this is my error. And then to find my confidence interval, my lower bound of my confidence interval is just going to be the mean minus the error. And then my upper bound is going to be the mean plus my error. So basically what that's saying is for our sample, we got the average or the mean GPA is 3.265. Now, we don't know if that's actually the mean GPA for all students, but that was the mean for our sample that we pulled, or the sample that I hypothetically sent the survey out to. And so, what this confidence interval is telling us is that we would expect that the actual mean of the entire population of students is between 3.02 and 3.5. Now, this may not actually be true depending on whether or not your sample was biased. Like, for example, if you surveyed, I don't know, a group that was more likely to have a high GPA, like if you were part of some club that focused on like academic excellence and you asked people to answer your survey there, that would be a bias in your sample, which means that this confidence interval might not actually be where the mean is, just because your sample was biased. But assuming that your sample is representative of the entire population, you would expect that your population mean with 95% confidence is between these two numbers. And then you could do the same thing for your freshman, sophomore, and junior and seniors one. And as you can tell, those ranges are much bigger, and that's just because these sample sizes were pretty small. So this would be an example of how you could calculate confidence intervals to communicate your data. Now, ultimately, what my question was is, does GPA depend on the grade level that you are in school? So if we look at the freshman GPA, the sophomore GPA, junior, and senior, you can see that they're different, but we need to determine whether they're significantly different. Because it could be possible that these GPAs are close enough that the differences between them are just due to chance based on the sample that we collected. So this is where hypothesis testing comes in. And if we look at the test 3 reference sheet, we can see that there's several different types of hypothesis tests. So the general strategy for any hypothesis test is that you're going to write the null and alternative hypotheses, and then you'll calculate the p-value and use that p-value to determine whether you should reject the null hypothesis or fail to reject the null hypothesis. So the question that you ask determines which type of hypothesis test you're going to do. So hypothesis tests for population means are the tests that you use when you're comparing your sample mean to an expected mean. So an example of this might be in the Skittles example. that I gave you guys earlier, let's say that in addition to looking at the colors of all the Skittles in the various bags, you also weighed the overall weight of the bag of Skittles. Um, so if you had done that, you could compare your sample mean to the population mean. And what you would say, or what you would use as your population mean in that case, is the weight that is claimed on the bag of Skittles. So, if the bag of Skittles says, like, oh, this bag of Skittles should weigh 200 grams or whatever it is. Then that would be your population mean. And if you got a mean that was, say, like 193 grams instead of 200 grams, you could use the hypothesis test for population means to figure out whether or not that is significantly different. And remember, you can either do left-tailed, right-tailed, or two-tailed um, hypothesis test for population means. And depending on what your question is, you need to determine which tail is going to be the most useful. So in my Skittle example, if my sample mean was 193 and the claimed mean or the population mean was 200 grams, um, usually people aren't going to complain if they get more Skittles than the bag says, but they will complain if they get less. And so in this case, I would probably do a left-tailed test. But some questions might be more useful to use a right-tailed test, where it only matters if the sample mean is significantly more than the population mean. And sometimes you're looking at, is it significantly different, in which case you would use a two-tailed test, where it matters whether it's less than the mean or greater than the mean. So that's an example of when you would use that. The hypothesis test for population proportions, if we go back to that color of Skittles example, you would have your different proportions that you had measured by finding the sample proportions. And if you looked up online on the Skittles website and you looked at their proportions, where they said, on average, a bag of Skittles will have this percentage of reds or this percentage of yellows. Those would be your population proportions. And again, you determine whether it's left-tailed, right-tailed, or two-tailed. And that would be how you would use that hypothesis test. So in both of these, you're comparing the sample, either mean or proportion that you found, to the mean that you expect, either based on. And these expected means or expected population or proportions, they're going to correspond to your null hypothesis. So in the example of weighing out the bags of Skittles, the population mean is the weight that's claimed on the bag. Because if that's my null hypothesis, that the weight or the average weight of Skittles is the weight that's claimed on the bag, I'm trying to either reject my null hypothesis or I may fail to reject my null hypothesis. In the proportion example, the population proportion would be the percentages that I found on the Skittles website. And the null hypothesis would be that the proportions are what the website claims. And then I would be looking at if the Skittles bags that I sampled disprove that null hypothesis. And I shouldn't say disprove. I would say that you reject the null hypothesis, which means that you have evidence to suggest that the null hypothesis is not true, in which case you can say that there is evidence to support the alternative hypothesis. So those are those two types of hypothesis tests. The other type you can do is hypothesis testing with two-way tables. So this one's really good if you're trying to compare two different variables. So this one potentially could work for my question because I'm trying to compare the school year that people are in and the GPAs that they have. So to set this up, if I were to do a hypothesis test with two-way tables, I would need to make a table that's one of these dimensions because we only have this table for these specific dimensions. So it could be 2 by 2, 2 by 3, 3 by 3, 2 by 4, 2 by 5, or 5 by 2. Um, so the way that I would categorize my data here is, first of all, I might say, okay, well, one of my variables is the school year that they're in. So I would have freshman, sophomore, junior, senior, and those would be my categories for one aspect of my table. Then I need to create my other categories. Now, since my GPA is number values, it's kind of hard to create categories because all of the numbers are different. But what I could do is I could lump them together. So maybe I might say, okay, well, I'm going to look at GPAs between 0 to 0.5. Then I'm going to look at GPAs from 0.5 to 1, and then go, 1 to 1.5, and 1.5 to 2, and so on, all the way up to a 4.0, because that's basically making it so I can categorize um, all of my GPAs. Now, you could also do things that are not numbers. Like if you wanted to find, is there a relationship between the grade level that you're in and whether you live on campus or with on campus or off campus housing? In that case, both of your variables are categories. And so you could fill out the other part of your two-way table in that way, where you have on campus housing and off campus housing. But for the numbers that I've got here, this test may not be the most effective because the size of this table that I would create, and I haven't even finished it because it needs to go all the way up to 4.0, it is way bigger than these table sizes that I'm given here. So I could still calculate a chi-squared value. However, I don't know what the critical value is that I need to compare my chi-squared value to in order to reject or accept my null hypothesis. So you may be able to find an expanded version of this table that does include more rows and columns. But for my specific question, there's another hypothesis test that will work better. And that's the ANOVA test. But I wanted to go through an example of what this would look like because for a lot of you, this two-way table may be the best way to answer your question because you have whatever categories you're trying to compare. When you're looking at the hypothesis test for two-way tables, your null hypothesis is that there's no relationship between those two variables, and the alternative hypothesis is that there is some relationship. Now, it doesn't define what relationship it is, but that there is some relationship between the rows and columns. Um, so if your categories have a small enough number of options to create a table that's reasonable for this test, you can totally go for it. But I'm going to use the ANOVA test, which tests whether or not the means are equal to each other. And this kind of relates back to what I was looking at here, where I've got my overall mean and my freshman, sophomore, junior, and senior means. And I'm wondering, are these significantly different from each other? Or is it possible that I got these differences just due to chance? So to do ANOVA testing, you need to use Excel. I don't think there's a way to do that on Google Sheets. So I'm going to copy and paste my data into Excel. And I need to set it up in a way that works for the ANOVA test. So the way that the ANOVA test works is you have your categories. You can either do them in rows or columns, but I'm going to do them in columns. So I have freshman, sophomore, and junior and senior. You have those in columns or rows. And then underneath them, or next to them, if you did rows, you're going to put all of the data that fits in that category. So I'm just copying and pasting my freshman, junior, and senior. and sophomore data. And remember, the null hypothesis for ANOVA is that the means are equal. So over in Google Sheets, I calculated out these means, but I need to decide whether or not these are statistically different from each other. Because the question I was trying to answer is there a relationship between the year of school you're in and your GPA? So one thing to note is that the ANOVA test will only work if you are looking at numerical data because it's related to means. Um, so the two-way tables that I was showing you guys earlier, that one could work with two qualitative uh, variables like being on campus or off campus compared to your year in school. That would work with a two-way table. And even if you have numerical data, you have to kind of split it up into categories anyway. But the ANOVA test has to work with numerical data. So if we go back to Excel, my null hypothesis is that these means are, or the population means that they represent are equal. So to do the ANOVA single factor, I'm going to select my input range, which I don't know why it's not selecting it. Oh, okay. Oh, maybe I have to type it in. Usually it doesn't do that, but we'll say it's D1 through G, what's the bottom row? 10 for our input range. It's grouped by columns. The labels are in the first row. Our significance level will be 0.05, and I'm going to output this on, let's say, cell D13. So when I run that, I get all of this information from the ANOVA calculation, but what I'm looking at is this p-value. So my p-value is telling me the probability that I get these different means, which they actually helped calculate them out for me too. So these numbers here are the same numbers that I calculated on the Google Sheet. But the p-value is telling me that it's 87% likely that the differences between these averages were just due to chance. And so since this p-value is not less than 5%, that tells me that I will not reject my null hypothesis. And for the data that I collected, it looks like the GPAs are about equal, regardless of which level of school you're in. Now, keep in mind that this data I did just make up. So this is not real data. So if you had actually sent out this survey, you might get a different result than that. But that's how I would use the ANOVA test, which is a form of hypothesis testing, to answer the question that I was looking at. So that was a really, really long explanation for this portion of the paper, but it's also the majority of the paper. So just remember your analysis needs to include confidence intervals, which can either be confidence intervals for the population mean or the population proportion. And then some type of hypothesis testing. So it can be any one of the three hypothesis tests on the reference sheet, or it can also be the ANOVA test. The one that I ended up using was the ANOVA test because of the question that I was asking. My guess is, though, that most of you, for the questions that I was reading as I was grading your assignments, most of you guys will probably be using hypothesis testing with a two-way table because a lot of you are looking at, is there a relationship between these two variables? So that's that part of the final paper. This part, displaying your data and results in an easily understandable way. You want to use tables, charts, and graphs. They can be pie charts, they can be histograms, whatever you feel like is going to convey your data in the most understandable way. For my specific situation, I I might have used a pie chart of how many freshmen, juniors, and seniors and sophomores were in my sample. And I might include that graphic in my conclusion when I was talking about biases. Because if you look at my sample size, I had more freshmen and sophomores than juniors and seniors. So that might be a potential bias in my survey that I might want to consider. And I could use a pie chart to illustrate what that bias could be. That might be an example of a pie chart I might use. Um, or I could also make a histogram of the GPAs overall to look at their overall GPAs, or you could make a separate histogram for freshmen, juniors, seniors, and sophomores. Basically, whatever types of graphs and charts you think are going to help display your results. And then the 20 points, you want to draw a conclusion based on your data. So when I did the ANOVA test, since my p-value was so high, my conclusion was that there's not a significant difference between the GPAs of freshmen, sophomores, juniors, and seniors. But again, if I had actually collected the data instead of making up the numbers, I might have got a different result. So that would definitely be one of my biases, is that my data wasn't actually real. But you'll just summarize any biases you think might have been present in that conclusion. So if you have any questions about your final project or your final paper, let me know. And again, I would highly recommend that you submit this by June 28th so that I can grade it over the weekend and give you one last chance to submit it on July 1st with any adjustments that I leave in the feedback. So I hope this video was helpful, and let me know if you have any questions. You're welcome to sign up for my office hour time slots as well. If it would be helpful to talk through which type of hypothesis testing or confidence intervals would be most useful for the question that you're asking. So thank you so much for your time, and I hope you have a good day.